So in this video, we will be discussing LAN security concepts. So this is one of the module in our bridging course, the SRWE, which stands for Switching, Routing, and Wireless Essentials. So the module objective is to explain how vulnerabilities compromise LAN security. So in this module, we'll be discussing these points: the endpoint security, access control, layer 2 security threats, MAC address table attack, and LAN attacks. So for the endpoint security, we will be explaining how to use endpoint security to mitigate attacks. So next is in the access control, we need to explain how AAA and 802.1x are used to authenticate LAN endpoints and devices. So for the topic of layer 2 security threats, we need to identify layer 2 vulnerabilities. And then for the MAC address table attack, so we need to explain how a MAC address table attack compromises LAN security. So MAC address table, so how it weakens LAN security. And then last is the LAN attacks. So we need to explain how LAN attacks compromise LAN security. So for the endpoint security, it's also subdivided into 4 points. First is the network attacks today. Second is network security devices. And then Cisco email security appliance. And then the Cisco web security appliance. So first, for the network attacks today. So the latest network attacks today mainly involves DDoS attack. So DDoS, which stands for distributed denial of service. So the DDoS attack is a coordinated attack from many devices. So its intention is to degrade and hold public access to organizations, websites, and or resources. So we also have an attack called data breach. So the data breach is attack that the organization's data servers are compromised to steal confidential information. So the organization's servers are compromised to steal confidential information. We also have the malwares. So the malwares is an attack in which the organizations host are infected with malicious softwares. So the examples for malwares are like Trojans, and then ransomwares. So for the next point, we have network security devices. We have here 3 devices: the VPN enabled router, the NGFW, and the NAC. So the VPN enabled router, so it provides secure connection. So it provides secure connection to remote users across the public network and into enterprise network. Next is the NGFW, which stands for Next Generation Firewall. So it provides stateful packet inspection and NGIPS. So NGIPS, which stands for Next Generation Intrusion Prevention System. It also provides AMP, or the Advanced Malware Protection, and URL filtering. And the next device is the NAC device, which stands for Network Access Control. So it mainly involves the AAA, which stands for authorization, authentication, and accounting. So later in this video, we will be discussing this. So the next topic is the Cisco Email Security Appliance. So Cisco ESA. So it is a device that monitors SMTP traffic. So SMTP is a protocol for sending emails. So it mainly involves emails. So some of its functions are block known threats, remediate against stealthware, malware that evaded initial detection. So it also discards emails with bad links. So this is Cisco ESA. So it also blocks access to newly infected sites and encrypt content in outgoing email to prevent data loss. So for the example, so we have here the threat actor. So on the left side, and now it sends an phishing attack to this host. So first it will go to the firewall, and then the firewall will send it to the Cisco ESA. So the Cisco ESA, so it analyzes this email, and then it logs it. So if it's a malware, so discards it. So the next topic is the Cisco Web Security Appliance. So if the Cisco ESA monitors SMTP traffic, then the Cisco WSA it monitors HTTP traffic. So it mainly involves websites. So some of its functions are blacklisting of URLs, URL filtering, malware scanning, URL categorization, web application filtering, and also encryption and decryption of traffic. So we have here an example. So the user here, so he wants to access a website here, then goes to firewall, and the firewall forwards the request to the WSA, and then the WSA analyzes it, and then it determines that it is a blacklisted website or blacklisted URL. And then what WSA do is it discards the request and then sends an access deny email or access deny a message to the user. So we are now in the access control of LAN security concepts. So the access control are subdivided into 4 parts: the AA components, authentication, authorization, and accounting. So the AA obviously stands for these 3. So the concept is very similar to credit card. So the credit card here identifies who can use it, and it also shows how much the user can spend, and keeps an account of items or services that the user purchased. So here, the AA provides primary framework to set up access control on network device. So the AA is also a way to control who is permitted to access a network, like I said earlier. So they authenticate what they can do while they are there, authorize, and also to audit what actions they performed while accessing the network or accounting. Now for the authentication, we have 2 common methods of implementing AAA authentication. First, we have local AAA authentication, and the second one is the server-based AAA authentication. So the main difference between these two is the local AAA authentication uses a local network device such as router, so as its database, and while this second one is it uses obviously a server for storing information about the user. So the local AAA authentication, it is also ideal for small networks, while the server-based authentication, it is ideal for the networks with many switches and routers. So as for example, we have here the local AAA authentication. We have here the remote client. So first, it establishes a connection with this router. Next, this router prompts the user, the client, for username and password. Next, after authenticating the username and password, so the user now or the client was provided access to this network based on the information in the local database. So next is the server-based authentication. So as you can see, we have here the server, and then so the router uses these protocols for communicating with the server. We have here the radius and TACACs. The remote authentication, dial-in user services. Akin po! Terminal access control systems, or the TACACs. Now, for this example, we have here the client. So it establishes connection with the router first, and then second step is this router prompts the user for username and password. So the third one is the router authenticates the username and password of the client based on the AAA server. And then the last step is the user now was provided access to the network based on the information stored in the AAA server. So the last two we have is the authorization and accounting. So the authorization is basically governs what the users can and cannot do on the network. And then for example here, so we have here the remote client, the router, and the server. So in this example, so we have here the session between the router and the server, and then the router requests the server for some authorization for this remote client, and then the server responses with pass or fail for authorization. And then we have also the accounting. So the accounting is just collects and reports usage data. So in this example, we have here the remote client, the router, and the server. When a user has been authenticated, the AAA accounting process generates a start message to begin the accounting process. So when the user finishes, a stop message is recorded and the accounting process ends. So in this example, so the accounting basically means it records the whole conversation. So now we are here to layer 2 security threats. So we can say that layer 2 is vulnerable to attackers or attacks. Now we have here the OSI model. So the network administrators routinely protect these layers from layer 3 to layer 7. So we can say that this layer, or the data link layer, is the weakest link in the system. Also, the network administrators, like I said, they implement security solutions such as VPNs, firewalls, and IPS. So we can say that if this layer is compromised, then all of this layer above it is also affected. We also have the layer 2 attacks and the layer 2 attack mitigation. So how to mitigate these attacks? So for the layer 2 attacks, we have MAC table attacks, VLAN attacks, DHCP attacks, ARP attacks, address spoofing attacks, and STP attacks. So these MAC table attacks includes MAC address flooding attacks. So for the VLAN attacks, we have the VLAN hopping and VLAN double tagging attacks. So for DHCP attacks, so it includes DHCP starvation and DHCP spoofing attacks. So for the ARP attacks, we also have the ARP spoofing and ARP poisoning attacks. So address spoofing attacks, it includes MAC address and IP address spoofing attacks. So and also for the STP attacks, so it includes spanning tree protocol manipulation attacks. So we also have the mitigation for that attacks. We also have for security, DHCP snooping, DI or the dynamic ARP inspection, and IP source guard or IPSG. So the port security is prevents many types of attacks, including MAC address flooding attacks and DHCP starvation attacks. So DHCP snooping, it also prevents DHCP starvation and DHCP spoofing attacks. So for the DI, it prevents ARP spoofing and ARP poisoning attacks. And last is the IPSG or IP source guard. It prevents MAC and IP address spoofing attacks. Now we are here to MAC address table attack. We have the MAC address table flooding and MAC address table attack. So the MAC address table flooding, it is an attack wherein the MAC address table of the switch was bombarded with fake addresses. So I can say that bombarded with fake MAC addresses. So as a result, the MAC address table, as a result, this switch will all flood the incoming frames to all of its port. So we also have here the example. So we have here the threat actor or the attacker. So it uses MAC off to generate some random MAC addresses to this switch. So as a result, this switch will send all the frames. So it floods all the frames to all of its port. And then this threat actor will capture all these frames. Now to mitigate this MAC address table attack, we use port security. So the port security, say the port security, then it allows specific number of MAC addresses. Now we are here to the LAN attacks. So the last topic for LAN security concepts. So we have here the VLAN hopping attacks, VLAN double tagging attack, DHCP attacks, ARP attacks, address spoofing attack, SDP attack, and CDP reconnaissance. So for the VLAN attacks, we have here the example. So the attacker configures his host to act like a switch. So after configuring, it can hops between VLANs. You can hop between VLANs. Next is the VLAN double tagging attack. So as the name applies, double tagging. We have here also the example here. So as you can see in the frame, we have double tags for VLAN. And then we have ways to mitigate these VLAN attacks. So first is to disable trunking on all access ports. Second is disable auto trunking on trunk links so that trunks must be manually enabled. So for the third one is be sure that the native VLAN is only used for trunk links. Now we will be discussing these three attacks: the DHCP attacks, ARP attacks, and address spoofing attack. So for the DHCP attacks, we have two types of this. The first one is the DHCP starvation attack, and the second one is the DHCP spoofing attack. So sa DHCP starvation attack, so the goal of this attack is to create DOS attack to clients. So the goal is to create denial of service attack. Okay. So the second one is the DHCP spoofing attack. So it provides false IP configuration addresses. So IP configuration parameters such as fake MAC address, then fake IP address, and also fake DNS address, DNS server address. So for the ARP attacks, we also have two types. So the first one is the ARP spoofing attack, and the second one is the ARP poisoning attack with man-in-the-middle attack. Okay, we also have the example here. So for the ARP spoofing attack, we have here the attacker. So he wants to replace the router as its default gateway. So he informs the LAN that the MAC address of this PC1 here is maps to its MAC address, which is the CCC, all Cs, and also for the PC1, so it also maps its MAC address. We also have the ARP poisoning attack with man in the middle. So I also have the example here. So in this attack, so So it replaces all its the MAC address of each other, the PC1 and the router 1. So it replaces its MAC addresses by his MAC addresses, the attacker's MAC addresses. Here. And then the last attack is the address spoofing attack. Okay, we have an example here. So as for example, my MAC is all B's. So in this attack, so it matches the MAC address of its target host, so which is also have the MAC address of all B's. So it matches that MAC address, and as a result, all of the messages or frames that must be sent to the PC1 is sent to the attacker. Now we will be discussing the STP attack and the CDP reconnaissance. So the STP attack is the network attackers can manipulate the STP, or the spanning tree protocol, to conduct an attack by spoofing the root bridge and changing the topology of a network. So attackers can make their hosts appear as the root bridges, and therefore capture all traffic for the immediate switch domain. So we have here the sample photo of the STP attack. So the first thing to do is the host or the attacker broadcast the BPDU, or the bridge protocol data unit, and it announces the low bridge priority to it is an attempt to be elected as root bridge of the network. So as successful, as mentioned here, so it also captures all traffic for the immediate switch domain. If successful, it captures all the frames here from the switch. Also, we have the CDP reconnaissance. So an attacker in the threat actor discovers the iOS version and IP addresses of the local switch. So we have here the sample Wireshark that displays the contents of the CDP packet.